Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to NPTEL course on groundwater hydrology and management. This is week 7, lecture 3. In this week, we are looking at multiple methods in increasing the recharge rate. This is because India is being seen an unprecedented use of groundwater, and with it, there is a lot of recharge needed to sustain groundwater use. In the last lectures, we looked at how the methods are devised. It is direct methods, indirect methods, and a combination of both. In today's lecture, we will look at the direct method and most important methods for India. The first one is the runoff conservation. As the name suggests, runoff is from your water balance equation we can get, which is the water which comes from rainfall, which is not going into the ground as groundwater recharge or storage, it just goes on the surface as runoff. There is a need to conserve the runoff, prevent the runoff from escaping the watershed. And it has multi-purpose measures. For example, runoff conservation can help in soil water conservation. It can help in afforestation because it can give water to forested regions and improve the forest cover. It can increase the agricultural productivity because now you have more water. You're lessening the loss of water from the watershed. You're keeping the water within the basin. And so there is more use for increased agricultural productivity. These are mostly preferred on low to moderate rainfall. If there's excess rainfall, you don't need to capture the runoff. Let it go, because if you capture runoff, then flooding will happen. So these runoff conservation measures are mostly needed for the low and moderate rainfall. In other words, in India, it is the arid or semi-arid conditions. Let's take Rajasthan, for example. There's only limited rainfall and occurring in very short time frame. And if you don't capture the rainfall as runoff and storage, etc., it just leaves the watershed. So it is very important to capture it. And also, there is a need of controlling runoff loss from basins across the world. This book, if you see here, it is the FAO's book on resource management for upland areas in Southeast Asia. Upland means it has a good slope. Okay, high hilly regions, etc. There's good rainfall in hilly regions, and if you don't manage it properly, then the runoff will just flow downstream and without any use for the upland communities. Upland, uphill, all these higher elevation lands are same meaning. Okay. So where does this understanding come from? The basic understanding comes from your water balance equation, where you have your precipitation, runoff in, runoff out, ET, groundwater in, groundwater out, and change in storage. Okay. If you don't, the point here which I am discussing is, if you do not reduce your groundwater out, that means you are reducing your storage because it's a negative. And assuming, like, for example, in this area, you don't have ET, so let's ET be 0, groundwater in is equal to groundwater out, so let it be 0, and there is no water coming in. So groundwater in is 0. And surface water in, no pipe connection, nothing is coming in. This is the upland. So what happens is your storage is nothing else but your precipitation minus the runoff, which means if you say there is 0 runoff, you close your basin, you control your basin without preventing water in losing, then the entire runoff is basically your precipitation or your storage is basically your precipitation that you're catching and keeping within the basin. These are called zero or closed basins because it doesn't let the water out. And to be honest, in some regions, these are needed because the water is not enough for the upland people. So moving on, we have these water balance equations and other equations that support that we need to capture the rainfall and also manage the rainfall very well. So these are runoff conservation. So basically, catch the rainfall, before runoff, etc. If you catch directly rainfall, it is rainwater harvesting. If you let rainfall convert to runoff and then you conserve runoff, then it is runoff conservation. So let's look at some methods. The first method is the bench terracing. I'm using the methods given in the CGWB manual, and I'll be taking some references from TNAU, FAO, etc. So what you here have is bench terracing, or terracing is converting a slopy land into terraces. Okay, you cut through in between so that you slow down water. So if I have it like this and water is falling, water flows down along the slope. Okay, it is much faster rather than going in steps. Okay, so if water is, for example, you have a slope and water hits, rainfall hits, then it quickly goes down the slope. However, if you make the surface as terraced, cut through in between, then water would flow and then go down like this, go down like this, go down like this, right? I'll use a different color. So this is your land surface. And then you have, so water will go like this, okay? So what is happening is you're delaying the water, and by delaying the water and hitting down, because it goes down, goes down, goes down, then here there is good recharge happening. And net groundwater is recharged. Okay, so see what is a quick example. We have these locations mostly in the high upland regions or high elevation regions where there's good rainfall, but because of the slopy land, water just goes down. So it is kind of a runoff conservation where you wait till the rainfall converts to runoff and then you capture it, make it slowly go down and then recharge it. So it starts with leveling of slopes. First, you make sure the slope is leveled, and then remove the any unleveling patterns like ditch or a gap, etc. So you make it leveled so that water can run smoothly, and adequate soil cover for irrigation is also needed. So you cut and then use some land where you can put the soil. So you need to get soil so that you can grow native species of vegetation or agriculture. Remember, in the example I showed, when you cut it, you can further reduce the speed of the runoff if you have vegetation, because vegetation can act like a buffer, and that buffer would make the water go slow. Okay, so here's what is happening. If you have just plain land, then cut the land and stuff, water will move down a little bit slower. But if you have your agricultural slope along with terrace farming and or native species, water will slow down. Once it slows down, it goes into the recharge. Need watershed area, the boundary of the watershed, and elevation map. The watershed area gives you how much rainfall is going to come, and the elevation gradient gives you how many contours you can space. Okay, so because I know how the elevation changes, I can say every 10-meter elevation difference I can put. If I don't know that, then what would happen is you will randomly put in these terraces and it won't work well. So the is you convert a slope into cutting by terracing activities, and then put soil there, because initially there won't be any soil. Bring agricultural related soil up and then put it there so that crops or new vegetation can grow. Once vegetation starts to grow, water will automatically slow down and then recharge, and also support the vegetation that is on the land. So FAO has given you multiple examples of these types, and which land uses you could use. For example, all these are cross-sectional views. So you have the land like this, you cut the land, and then you can see from the cross-section what is the relevant construction. So if you look at here, you could see that first initially dashed line is the initial line. It is a slopy slope. And then you cut it, take the soil, put it down in the next terrace, or you can remove it and put agriculturally active soil, and then you can make some field, okay, agricultural field or trees, something that can help slow down the water. So for rice or for flood irrigation, you can keep it gently sloping, not high sloping along the thing. Along the slope, because you do need water to stay there for long. Rice takes a lot of water. For mainly rain-fed crops or irrigated crops in dry season, then there's more steeper slopes. It's okay to have a steeper slope. Remember, to convert a slope to a straight land, you have to do a lot of work, and a lot of machinery or construction is needed, like in terms of removing the soil and cutting, terracing. So understand if you have that bandwidth. These are the continuous type. Okay, discontinuous type include for upland crops, especially semi-permanent crops, small crops you can put. You can have trees in between the crops, like fruit trees for orchard terraces. And then you have individual plants, big trees or big plants can be kept. And then you can also have a mixed farming. So you can have both a terrace and a tree, and a terrace and a tree. So if you go to regions like Ooty in South India, in Tamil Nadu, you could see that along the slopes, they make tea plantations. And to keep the soil holding on better, and also to help the slowing down the water, you have eucalyptus or other trees in between the tea plantation. So yes, you have to sacrifice a bit of the land, but it is good on the overall cycle. The next one we want to see is contoured bunds. So similar to your terracing, however, this is not along the hill slopes. Okay, terracing is a very high elevation, whereas contoured bunds are construction of narrow-based trapezoidal bunds. It's just a bund along the semi-sloping land. It's not a high-sloping land, semi-sloping. Let's see how they make it. So you have a slope or a land, piece of land, you make a trench or ditch. You have to dig a little bit, put the soil out along after the ditch or trench. So when water comes, and you can also have stone or vegetative barriers to slow down the water. So the idea is to slow down the runoff or capture the runoff. So if runoff comes, it first slows down and then goes into this trench. Okay, here's where water starts to rise, and then it is also not overflowing because you have this bund which is slowing down the release of water. So once this ditch is full of water and the enough water is available for going over, it goes over. Okay, now the point is, how does water recharge? Along the trenches, water recharges. Along the trenches, water recharges. In the previous, I said every step there is a recharge. Here, every trench or a ditch, there is a recharge. Okay. Leveling of land is needed before you start these processes, because you want to remove the irregularities, uneven surface you need to remove. Otherwise, water would go somewhere else, not into the ditch. Your whole idea is to get water into this ditch. From here, it recharges. When you slow down here, yeah, there is some recharge happening, but most of the recharge will happen here in the ditch. So a lot of surveying is needed to get the elevations correctly to level it. And the elevations are very, very important for these kind of studies. And it is also important to consider the spacing between the trenches. If you have too much trenches, then the land is lost, the stability is gone. And the cross section has to be done well to capture how many interspacing of trenches has to be there. Okay. Need to change as needed for undulating land. Sometimes the spacing is not the same. If I say, for example, I have 10 elevations, so do I have 10 trenches? No. It depends on the land also, not only the elevation. So the land is also important. The cross-sectional view here shows how this is done by CGWB. For example, the water is coming, it goes into the trench, recharges down, okay, and then the water is prevented from moving readily out, but still water would go slowly out, and then another trench goes down, recharge, and then goes up again, and then recharge again. So the recharge happens along the trenches and along where the water flows, but especially in the trench, there's more water recharge. Let's take this example. You have 116, which is your elevation, and then 100 is another elevation. Water runoff flows from high elevation to low elevation. So from 116 to 100, water is moving slowly. And while it moves, these trenches are there to capture the water. And after the water, there's a bund. Okay. So these bunds actually prevent more water from flowing. Okay. So water is flowing like this. And this is where we capture it in the cross-sectional view. It goes in and then the bund. And then goes in and over the. While it goes into the trench, it is recharging. Hope this is clear. More schematics are given in the CG, which I've shared earlier in the last class. Then we move on to gully plugs, nala bunds, and check dams. The spellings of nala is different in different regions, NALLAH, but the meaning is the same. Okay, so there are certain similarities between a gully plug, nala bund, and check dams, but there are also some subtle differences. I will go through this in detail. And more importantly, these all work on the principle of if you reduce the runoff, if the runoff is reduced, slowed down, or conservation of runoff, then water will go into the recharge. Let's look at the definitions. Constructed to check the flow of surface runoff. As the word check dam is, it is made to check or slow down the flow of surface runoff. Okay, while you check, there's a checkpoint, there is a traffic moving, and when there's a checkpoint, people move slow, right? So that is where you temporarily slow down the runoff, and the runoff goes in as recharge. So here you could see water can come, and then the gully is plugged. Okay, what is a gully? A gully is a sudden dip in the elevation where water is flowing. It could be a stream order, very small stream order, etc. So along the stream order, if you put stones and other things that is plugging, like a plug you put for leaking water, like a tap. So here, if you put a gully plug, then water will go through and recharge, and then still go through the horizontal way. Our aim is to get water vertical from horizontal. So for example, here water will be flowing and then hit this rock, still it will flow, but some water has gone into the groundwater recharge because you're slowing down the water. And what you put in the gully depends on what materials you have. It can be rocks, pebbles, and other soil materials, or it can also be some seedlings and saplings, wood, etc. So that is the beauty of this technique. It is not that expensive. This community participation can help in building these structures, mainly to slow down the water and get the runoff in. Construction can be of different civil work and levels. Okay, civil means civil engineering or masonry, where you can have multiple constructions or less construction. Very important to understand the bank of these gullies or stream models. If the stream or the gully is not stable, then when you slow down the water, what happens is all these material can collapse. Some collapse is happening here, but mostly this is where the maintenance is very much needed. Different materials can be used, ranging from wood, loose or dry stone, big rocks, or very loose stone that can be clubbed together and used. You can use wire, woven wire, like nets can be used to slow down the water, and a combination of rock and wire can be seen here in this diagram. So all these can be lined across the gully, and so that water can move and then slowly get infiltrated. As I said, you can also put saplings and seeds as the FAO has recommended on the top figure. So what is the big difference between the other methods? So gully plugs are the first order stream, which means it's a very small river or a stream network that connects to a river. And so the water volume and the discharge velocity is small. So even though it is low, you're trying to reduce it so that you can have more recharge. Nalas would be of a higher order. It's the same technique, but higher order. So once the order is higher, you would expect to not use the same wood or dry stone, but you would use more like cement and rocks. In other words, if you look at where these are more appropriate, the gully plugs are more appropriate in the forested zones where you have water coming slowly. Okay, rainfall happens and the stream is just starting. The starting of a stream is along the forest. So there, the stream, the first order stream, you can put a gully plug, and right there, water can be used. In fact, beavers, it's an animal called beaver. You can Google out Beaver. So these beavers actually stop these small forest rivers by making these dams, gully plugs, and in that they can catch fish, or also they get more water so that they can enjoy the environment. So check dams are of higher stream orders, and it has a gentler slope. If it's too much slope, the water cannot stay, so it is gentler slope. Let's look at some examples. So this is a nala, a small nala built across the river, as shown in the CGWB report. And check dams are much bigger. It is smaller than a dam, a large irrigation dam, where you cannot walk and run like the kid is walking. However, it is bigger than the nala. Nala is much smaller, and also please remember all these are expensive. There is money needed for these. So it depends on not only the water which is coming, but also how much money is available for these kind of activities. And if your village or panchayat has enough money, then mostly they go for check dams. Lesser money, they would choose the gully plugs or nalas as and when needed. And also these check dams can be in a cascading effect. So these are called cascading check dams, which means one after the other after the other. Same way you did look at the terrace farming, where you had a terrace, another terrace, and another terrace. So, or a trench, contour trench, a trench, and then another trench along the elevations. Here, what happens is you have small check dams where water is stored and then overflows, and then stored and then overflows. So wherever it is stored, that is where the recharge is happening. So here groundwater recharge is happening. Here it is slow down. Not much is saved behind the gully plug, but still some recharge is happening. Whereas here also there is recharge. Let's look at the next one to slow down the runoff and capture is percolation tanks, village tanks, and ponds. What you see on the top is farm ponds or small village farm ponds, where along the Konkan region, Maharashtra, you could see that big ponds are created to capture the runoff. So while runoff is coming down the hills, for example, this is a hill, and where it is, when water is coming down, it is getting stored in these farm ponds. And from there, the ponds, the water recharge is happening. Okay, it's basically evacuated land along the slope or along the land surface where water runoff can be captured. But make sure the runoff comes there, otherwise there's nothing to store. So percolation tanks, how they work is a small check along the river, and it has good gravel and material underneath the dam to enhance percolation. Okay, this is the difference between a check dam and a percolation pond. Whereas a check dam would allow the water to go and then it overflows and then goes. Here, you're trying to create a pond. You don't see a pond overflowing, not often. So it's you take water from the main channel and then you put it in the pond. Okay, so similar to Nala, but bigger catchment areas. It has much bigger catchment areas, no outlets, gateways, but spillway. As I said, you don't have a gate to open and release the pond water, but spillways are there, a small embankment, and along the embankment, the water can go. Should have high permeability. The soil or the land underneath the pond has to have high permeability. So it is not just evacuating the soil and then you put the water in. Here, what mostly is done is you can line certain types of soil, rocks and materials which have high permeability, so that when you put the water in, it starts to increase the infiltration. Okay, many designs exist. We will see some of them. So in this percolation pond, what is you can see is it is along the slope, and water is being first shunted into the pond area. Once the water is ponded up, then water starts slowly to recharge. Percolation tank is along the river, and a tank can also be off the river. You can just take the water and put it in the tank. So mostly when, what is the difference between a tank and a pond is, tanks can also be along the river channel, whereas ponds are normally kept away. Okay, and they need not be just fed by the river, but it can also be fed by rainfall. Small barriers to promote groundwater recharge, similar to farm ponds without lining. So normally, farm ponds have lining, which means cement line underneath. So when water flows, it can not go groundwater, where village tanks and farm ponds need not want recharge. All they want is to store the water, and then they use the water later for irrigation. Whereas percolation pond, the aim is to get water in the groundwater. Okay, there is evaporation loss because when you pond the water, there is evaporation loss, but you are also augmenting the percolation, not infiltration, percolation. Infiltration is just going in very slowly. This we saw in the previous lectures, whereas percolation is going into the deep aquifer. Village tanks are somewhat outside of the main river channels. It's a tank. So normally tanks are also away from the river channel, wherein water can be put in from the main channel. So, or runoff can be routed into the tanks. Whereas a pond is similar to a tank, but smaller in size, and also water can be put in through runoff routing. Okay, so we route the runoff into the percolation pond. So the village tank, what is new about this is, village tanks were never for groundwater recharge. It was a water body that the village would use for drinking, bathing, domestic use, and or taking the livestock for water. However, the CGWB manual and many studies have recommended the use of village tanks as groundwater recharge. So what you need to do is make sure you remove the cement lining on the ground underneath the tank. So when you expose the tank to the natural soil, then water recharge can happen rather than having a cement line. So normally a village tank is like a large swimming pool, very large swimming pool if it has cement. Otherwise, it is just made of tarp. Some people put plastic sheets underneath to prevent the recharge. But the idea here is, if you manage the runoff to capture all the runoff effectively and put it in the village tank, you could still get recharge going down and also use the water for domestic on the surface. The next one I would like to touch upon is modification. So a modification of stream channel and augmentation is also very necessary for successfully reducing the runoff, uh, conserving the runoff for recharge. So what does it mean? So here what you see from the EPA book is that when a river is flowing, when a stream is flowing, when a water runoff is flowing, okay, if it is made to flow in a very concentrated way, then fast it will go and less recharge is happening. If it goes in a tortuous way, there is some water that can be recharged. However, still the water can go fast. However, but if you make the stream go in a wide channel, okay, rather than a small channel, if it goes in a wide channel, then water will be spread across and then recharge can happen. Just look at this image. So here what is happening is the river is flowing in a very small concentrated way, even though the land is available. So there is less recharge happening. But in this system, all the other banks are protected and dug deep. Then the water spreads. Once you spread the water, there's more connection between water and land area, the surface area, and then recharge happens. So like this. Initially, this was all full water flowing, but slowly what happens is at this part it gets deeper. Okay, when it gets deeper, then the other land is not having water for recharge, only water recharge happens here. So the idea is to modify or manage the stream channel to increase the connectivity of water and land to recharge. Area where flows occurs only in limited part of the valley. For example, valley is along the slopes also. It happens only in a limited section. If you see a valley, even the Ganges valleys and basin, the bank is so big. However, water flows in a very small area. And only in that area, water is recharging. However, if you make the water flow like in a spreaded fashion, then more recharge will happen. Aim is to increase spread area to have more infiltration. So you spread out the water to have more infiltration. It is similar to your flood irrigation method. Here you're doing it inside a river channel. Bank stabilization is important. So as and when this happens, you need to make sure that you clear the sediments. So what is happening here is when water is flowing, here sediments are depositing and only water is flowing in this area. Slowly the sediment deposit is high and water only flows in the central region. What the idea is to make sure you push all the sediment out so that water can still flow. Then that is called bank stabilization. The common methods are widening. You widen the area of where the water can flow or widen the stream channel. Leveling, you keep it on the same level. Like here, all the water is on the same level. In-stream ditches. So along the stream, you can have multiple ditches where sediments can be deposited rather than at one location depositing. In-stream levees, like this example, a levee is a small check dam kind of thing, but not like a dam. It's just a small, like a speed breaker within the river. So when the water is flowing, it slowly goes above and then goes down. And while it goes up and down, there is some gravel fill here. A different material is filled so that water can recharge. Low head check dams is the same as I said, it's in-stream levees. So you can have a small check dam, but not like a check dam where it's big and then it stops the water. It is just there to, so that water can go over and then slow down while it goes over. So with this, I think we have covered the major factors for conserving runoff and recharging it through direct methods. I will see you on the indirect methods and other methods for groundwater recharge in the next class. Thank you.